Very good morning, my dear students and friends. And in today's YouTube video, we are going to learn about the development of the lateral surface of a tetrahedron. So, basically, you should know what a tetrahedron is. Friends, a tetrahedron is a triangular pyramid in which all the four surfaces that is 1, 2, 3, and 4, are all triangles, and they are all equilateral triangles. And all these edges, 1, 2, 3, 4, 5, 6 edges of the tetrahedron are equal in measurement. And friends, if we consider a pyramid, a pyramid will have a base. If it is a triangular pyramid, it will have three triangular faces on its lateral surface, and all these are isosceles. Whereas in case of a tetrahedron, as you can see, all the sides are equilateral triangles. This is what the difference is between a tetrahedron and a triangular pyramid. Friends, in today's session, we have a problem on a tetrahedron which is having edges measuring 30 mm. All these edges measure 30 mm, and you resting on one of the triangular faces on HP such that a side of it is normal to VP. Friends, when you see this triangle resting on one of the triangular faces on HP, friends, you can see in the front view a triangle, and in the top view an equilateral triangle with all the corners of the triangle joined to O, the center. So we will commence the problem by drawing the front and top views of the tetrahedron. So let me mark XY, the line of intersection of VP and HP, and we will mark in the top view a triangle, an equilateral triangle having side measuring 30 mm. So all these sides measure 30 mm each. So I will mark 30 as the side of the tetrahedron, and we will number this or name this as ABC. So this is A, this end is B, this is C. We will bisect any two adjacent sides and obtain O, the center of the triangle. Join O to all the corners, O to A, O to C, O to B. Friends, these three lines OA, OB, and OC represent the top view of the three edges connecting O to the base of the solid. Friends, let us obtain the front view by projecting lines from A, B, and C like this. And here, friends, you get the base of the tetrahedron on which it is going to rest. We'll call it as A dash, B dash, C dash. This is a triangular face which is on HP. Next, friends, if you see the data, they have given only the side of the tetrahedron. Nothing is mentioned about the height. So here, even though the problem looks very simple, you should know some of the important points, how to obtain its vertical height. Height means height from the tip of this to the center of the base. So friends, we have already drawn the base of that tetrahedron. Now we have to get what is called the vertical height of the tetrahedron. Sorry, it is to be 40 here, by mistake I've done 30. So this is 40, not 30. So friends, how to obtain? Now we have O. Through O, you can write a vertical line, On this, you should get the vertical height of the tetrahedron. If it were a pyramid, they would have given the height as 40, 60, etc. Here it is not given. I will tell you how to find out. Friends, we have got this OC. OC is the top view of one of the edges or sides of the tetrahedron. You know, all the sides measure 40. Now taking C dash as center and 40 millimeter as radius, I am going to strike an arc. This will have a length equal to 40 millimeter. And friends, this is O, the tip of that this tetrahedron height, and you will join O to all these, O to A, O to B, then O to C we have joined. So this is say O1, the center of the bottom face. So this is very very important, because when you are going through a problem on a tetrahedron, the height will not be specified, and you should know how to obtain the vertical height O1, or you can say O dash, O1 dash. Friends, this is how the tetrahedron looks in the front view and the top view. So this is the top and front views of the tetrahedron. Then comes drawing the development of the lateral surface. Friends, in the question it is specified, it is cut by a horizontal section plane at a height of 25 millimeter from the bottom face. Bottom face is A dash, B dash, C dash. So I am going to mark a point at a height of 25 millimeter from the bottom face. This is 25 mm specified distance of 25 millimeter from bottom face. So friends, the section plane SS is passing through this. So any horizontal section plane is seen as a line in the front view. So friends, I am going to draw the section plane passing through this, and I represent the section plane as SS. So SS is the horizontal section plane that is cutting this this tetrahedron at a height of 25 millimeter from the base. And friends, now this section plane is cutting the slant edges OE and OB here, and that of OC here. So you are going to get 3 points on the inclined edges of the tetrahedron. Let us come to drawing the development of this. Friends, you see here, this OC is the top view of this slant edge, and since this is 40 mm, the true length, so this is parallel to VP, this is the true length. Hence friends, I am going to draw a vertical line of length is equal to 40, that is the true length. I will say TL is equal to 40. I will make it as, or mark it as O. With O as center and radius equal to 40 millimeter, friends, I am going to draw an arc. So this arc is drawn with center O and radius equal to 40 millimeter. I have drawn an arc. On this, friends, you know very well, all the three edges of the triangular face on the lateral surface are all equilateral triangles. So if this is 40, this should also be 40, and all the three edges in that development should be equilateral triangles. Friends, and here you can just start the development from any point. Say I am starting from A. Now from here I am going to step up 40 millimeter, again 40 millimeter, once again 40 millimeter. So friends, this length is 40 millimeter. The arc I am drawing here are using 40 millimeter radius. So friends, let me join all these to the O, to O. So O to this, by thin line to start with, O to this. And see, similar to any of the pyramids, the bottom face will have the straight edges. So I am going to join this by a straight line. this by a straight line and this edge by a straight line. And if I am starting from A, this is B, this is C, and again this is A. This length is also equal to true length, is equal to 40 mm. That is the radii, same radii length they will have. Now friends, this figure with the three triangles, and you should remember all these are 40 millimeter in length, 40, all of this 40 length, this also of length 40, this also of length 40. This happens only in case of a tetrahedron and no other solids. Friends, now let us transfer the points where the section plane is cutting the solid to the corresponding edge in the development. If you observe the front view, the edges OA and OB are cut here, but these two are not the straight edges or the actual size or true length. So I am going to transfer this point to the true length line. This is TL, which is equal to 40. So on OA and OB, I am going to mark this distance on OA and OB. Say somewhere here. This is on OA, and also on OB. Friends, next, this is OC. OC is cut here. So this is the true length. Hence, I am going to transfer directly this distance on OC. On OC. Friends, you got 3 points. We will number them as 1. This is 2. This is 3. Again, this is 1. So 4 points you have got, and we will join all these 4 points by straight lines. So like this, we are going to join all. And friends, the portion below the section plane, that is this part of the tetrahedron, is retained. We will call this as part P, and the development we are trying for part P. So the portion above that is thrown out, assume it is not there. So the complete base should be there. Complete base means you will have the edges AB, the edge BC, edge CA. And here the portion from here to here, that is point 1 and 2. This is 1 comma 2, and this point is 3. Portion below this, that is 1A and 2B, is retained. So 1A and 2B is retained. Finally, portion OC below this is retained. Friends, this figure shown in dark lines will represent development of P, the lower part of the tetrahedron. And friends, here, these 3 figures you get here, they are all trapeziums. So, that is to say, the side 1 to 2 is parallel to AB. Line 2 to 3 is parallel to this. Line 3 to 1 is parallel to this. And friends, finally, the development, whatever you have got here, is 3 trapeziums, like this. Trapezium, this is side 1 to 2, and bottom is AB. Like that, you will have 3 such trapeziums in the development. And also you can observe here, whenever any of these pyramids are cut by horizontal section planes, irrespective of the orientation of the base of that tetrahedron, you get the same, or the lines at the top are all parallel to lines at the bottom, like what we have done in other pyramids. Friends, I hope the presentation was interesting and useful. And if you like this video, please do not forget to share this with all your friends. Have a wonderful day.